5. Angle relationships in circles. Essential question: when a chord intersects a tangent line or another chord, what relationship exists among the angles and arcs formed? Our first theorem is the tangent and chord theorem. Notice that if a tangent and chord intersect at a point on the circle, which is right here, then the measure of the angle formed is 1/2 the measure of its intercepted arc. So the angle formed by the chord and the tangent, this angle, will be 1/2 of the arc that's inside the angle. The same is true for angle 2. This formula, 1/2 the intercepted arc, is the same formula we use for inscribed angles. So the measure of angle 1 will be equal to 1/2, and the arc that is inside the angle is this arc right here, and that is 130. So 1/2 of 130 will be 65 degrees. In this case, we are being asked to find the arc, and we are given the angle. We can still use the formula. The angle is 1/2 of the intercepted arc, and we don't know what that intercepted arc is, so I'll just write it out. And then to get the arc by itself, I'll times each side by 2, and so that arc will be 250 degrees. The other angles that we're going to be working with is an angle that we've already talked about. This is called the inscribed angle, where again the vertex is on the circle. But notice we're going to work with angles whose vertex is inside the circle, and we're also going to work with a vertex that's outside the circle. The first one will be angles inside the circle theorem. So we have two chords that intersect inside the circle. The measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if we're talking about angle 1, then the intercepted arc for angle 1 is this red arc, and its vertical angle will be the blue arc. And so angle 1 will be 1/2 the sum of the two arcs. To find angle 2 is the same thing. Angle 2 will be 1/2 the sum of the intercepted arcs for the arc that is intercepted by angle 2 and its vertical angle. So to figure out what x is, we are going to take 1/2 of the intercepted arc, and the arc that is inside this one that for angle x here is 156. And then we look for its vertical angle, which is 130. So that's going to be 1/2 of, and that's 286. And when we take half of that, that's 143 degrees, and that's how big angle x is. Let's take a look at using the theorem again to figure out an arc. We have the angle, we have one arc, but we don't have the other arc. So the angle 60 is equal to 1/2 the intercepted arc, which we don't know, we'll call it x, plus the measure of the arc of its vertical angle that's inside the vertical angle, which is 25. When I do a problem like this, I like to multiply both sides by 2 first, get rid of the 1/2, and then I go ahead and subtract, and so x will be equal to 95 degrees, and that will be the arc, the measure of that arc. The next theorem I'd like to talk about is the angle with a tangent and a secant, or two tangents, which is this case, or two secants. And they all have something in common. They all intersect outside a circle. When that happens, the angle formed is 1/2 the difference of the measures of the intercepted arcs. So we have this outer arc, and we have this inner arc closer to the vertex of the angle. And so measure of angle 1 is equal to 1/2 the outer arc minus the inner arc. And the same thing happens for this angle that's formed by two tangents and this angle that's formed by two secants. All right, let's go ahead and do this problem. Notice this is an exterior angle. Notice it's formed by a tangent and a secant. We have an outer arc and we have an inner arc. So x will be equal to 1/2 of the outer arc, which is 178, take away 76. So x will be equal to 1/2 of 102, and then 1/2 of 102 will be 51 degrees. And that's how big that angle will be. Again, we have an exterior angle, we have an outer arc, and we have an inner arc. Our angle 20 will be equal to 1/2 of the outer arc, which is 80, take away the inner arc, which is x. And again, I like to get rid of the 1/2. So that's 40 is equal to 80 minus x. And then so negative x is equal to negative 40. And then we can say x is equal to 40. All right, these are formed by two tangents. And again, we have an outer arc and we have an inner arc. Now, because we are working with the whole circle, this inner arc is just the rest of the number of degrees from 360. And so that arc will measure 120 because this arc and the outer arc must add up to 360. So x will be equal to 1/2 the outer arc minus the inner arc. And then that answer will be 120, and 1/2 of 120 is 60 degrees. We're going to do the same thing here. This time we have the angle. 60 is equal to 1/2, and we want this outer arc. We don't have a representation for the outer arc. We do know that it represents all of this right here. Let me get red here. It represents all of this right here is the outer arc. And remember, the outer and the inner add up to 360. So this must be 360 minus x. And that's what we want to use to represent the outer arc. So this will be 360 minus x, that's the outer arc, minus the inner arc, which is x. So remember, we're subtracting two arcs, the outer arc and the inner arc. This will be 120 equals 360 minus 2x. Now, I like to bring the 2x to the other side so it's positive. So this is 2x. And then I like to subtract 120 on both sides. So that'll be 240. And therefore, x will be equal to 120. Okay, our next key idea is circumscribed angle. Circumscribed, just like circumscribed means a circumference means the part that's outside the circle, the circle part going around it. Circumscribed means to go around the circle, but in this case it's an angle. So this angle is going around the circle, and it is a tangent. It's going to intersect here at 2 points. So we call this a circumscribed angle. And if the angle is inside, we call it an inscribed angle. And we have worked with those kind as well. But this is circumscribed. There is a theorem about circumscribed an angle theorem. So it talks about the measure of a circumscribed angle. So this angle is 180 minus the measure of the central angle. So if we know this angle, then this angle right here is 180 minus that. Well, if we're working with 180, that means that these two angles are supplementary angles. Now, let's think about this. This is a quadrilateral. and this is a right angle, and this is a right angle. So 360 degrees are in a quadrilateral. If you subtract 180, then the two angles left that are not right angles are going to be 180 degrees, which is what we call supplementary angles. All right, so to do this particular problem, remember these are the right angles. And we know that in this quadrilateral, these two angles have to add up to 180. And in order for that to happen, x will have to be equal to 45 degrees. Okay, in this particular problem, be careful. We are not working with a central angle. This is an inscribed angle. So if it's an inscribed angle, let's think about it. Let's go ahead. We're wanting inscribed angle. Well, let's go ahead and draw the two radii. And when we draw the two radii, now we have this picture right here. We have the two radii that are making a right angle. Here we go. And therefore, this angle inside has to be 150 degrees. Well, if that central angle equals 150 degrees, then this arc must also be 150 degrees because the central angle and the arc that it intercepts are equal to each other. Now, in order to figure out x, remember, is an inscribed angle, and it's always half the intercepted arc. So x is half of the central angle, or 75 degrees.